Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 4-ethynyl tetrahydropyrin, a terminal alkyne attached to C4 of a tetrahydropyrin ring. The product is a gem-dibromocyclopropane, specifically a 2,2-dibromocyclopropane fused to the tetrahydropyrinyl group with defined trans stereochemistry of the H atoms on C1 and C2 of the cyclopropane ring. Moving on to the next step. To form a gem-dibromocyclopropane from an alkene via carbene addition, Simmons-Smith type or free carbene from CHBr3NOH, we first need an alkene, cis or trans. The terminal alkyne must be partially reduced to an alkene. The stereochemistry of the product, trans H's on the cyclopropane, meaning the two substituents, H and the ring are trans, indicates the alkene precursor must be a trans, E, alkene, because carbene addition to alkenes is stereospecific. Syn addition of CBr2 to a trans alkene gives a cyclopropane with trans substituents. Moving on to the next step. To reduce a terminal alkyne to a trans, E, alkene, one uses dissolving metal reduction, Na in liquid NH3, Birch-type reduction of alkynes. This gives the transalkene. To reduce a terminal alkyne to a cis, Z, alkene, one uses Lindlar's catalyst, H2PD CaCO3, poisoned, or H2PD BaSO4. Since the product requires a transalkene intermediate, NaLiC.NH3 is the correct first reagent. And for the final step, the product has two bromines on the same carbon of the cyclopropane, gem-dibromo, which is characteristic of dichlorocarbon or dibromocarbene addition. CHBr3NOH, delta, generates CBr2 dibromocarbene, which adds to the alkene to give gem-dibromocyclopropane. CHCl3NOH generates CCl2 dichlorocarbon, which would give gem-dichlorocyclopropane, not matching the product. Heat, delta, is needed for CHBr3NOH to generate the carbene efficiently. Option A. NaLiC.NH3, first, to give transalkene, then CHBr3NOH, delta, second, to give gem-dibromocyclopropane via CBr2 addition. This matches the required sequence and the product structure with Br atoms. B. H2PD CaCO3 gives cis-alkene, carbene addition to cis-alkene gives cis-H substituent relationship in cyclopropane, not matching the trans product shown. C. NaLiC.NH3 gives correct transalkene, but CHCl3NOH gives CCl to gem-dichlorocyclopropane, not dibromocyclopropane. D. H2PD CaCO3 gives wrong alkene geometry and CHCl3NOH gives wrong halogen. Therefore, the correct answer is A. Therefore, the correct answer is option A.